Ever seen a breathtaking 3D data visualization and thought, wow, I wish I could create that? Today you will learn how to build stunning 3D plots using advanced Matplotlib techniques. Whether you are an aspiring data scientist, engineer, or just a curious coder, this section is packed with skills you would love. Let's dive in. Hi, welcome back to the channel. Today we are leveling up your visualization skills with advanced 3D plotting in Python using Matplotlib. Here's how this section works. I will explain what we are doing at every step, code it live, and break down every tricky concept. By the end, you will have the confidence to tackle your own 3D visualization projects. We'll start with the basics and then build up to a real-world example. Ready? Let's code. Before we create visualizations, we need to set up our tools. Let's install and import the libraries we'll be using. Here's what they are and why we need them. Now, why use libraries? NumPy helps us handle data efficiently. Think of it as your power drill for numbers. Matplotlib.pyplot is the toolbox for making beautiful visuals. And finally, npl2kits.mplot3d is our gateway to 3D plotting. Make sure you have them installed. If not, just run pip install matplotlib. Alright, let's start with something simple. 3D scatter plots. Imagine you are plotting the locations of stars in the galaxy or cities on Earth. First, we need to generate some random data for this. Here I'm using NumPy to create 50 random numbers for each axis. A round function generates numbers between 0 and 1, and multiplying by 10 spreads them out to a more interesting range. Now we'll create a 3D plot. Watch closely. Let's set the size of the figure, then add a 3D plot. This is where the magic starts. This creates the canvas for our plots, and add_subplot with projection equals 3D gives us a 3D space to work with. Next, we scatter the points in 3D space and make them visually appealing. Here's what's happening. I'm scattering the points, coloring them based on their Z values, and using the Viridis color map for a sleek gradient effect. The marker equals 0 ensures they are circular dots. Finally, let's add labels and display it. Here you have it, a clean interactive 3D scatter plot. The labels and title make it easy to understand what you're looking at. Simple, right? Time to level up. Now let's plot a 3D surface. Think of this as mapping a mathematical equation into 3D space, perfect for visualizing terrains or wave patterns. First, we'll create the grade data. Let me break it down. Clean space creates evenly spaced values, while mesh grid turns them into a 2D grid. Then we compute Z using the sine function for a wave effect. Now let's plot the surface. Plot_surface creates a smooth surface with colors transitioning using the color warm color map. We set edge color equals none for a cleaner look. We add a color bar for context and show the plot. The color bar tells you what the colors represent. Here, the Z values. And with that, you've made a dynamic 3D surface plot. Let's wrap up with a practical example, visualizing terrain. Imagine you're modeling mountains for a game or a simulation. We tweak our surface plot to look like a landscape. This equation combines a wave-like structure with an exponential decay to create a realistic hill effect. Pretty cool, right? Visualization isn't just about data, it's also about storytelling. Let's customize our plots to make them not only more informative, but also visually striking. Have you ever wanted to see your plot from a different perspective? With 3D plots, you can. Let's change the camera angle to highlight specific details. Here, a leaf sets how high you are looking from above, and a zoom rotates the view around the plot. Experiment with these values to get the perfect view. Sometimes you want to call out a specific point. Maybe it's an outliner or just something cool. Let's annotate it. This places a text label at the coordinate 0.5, 0.5, 0.5. Perfect for marking important spots. Want to make your plots pop? Lighting and shading can add depth and realism. With shading on, your plots look more dynamic. It's a small change with big impact. Creating stunning visuals is great, but what if you want to share them? Let's learn how to save your plots for presentation or reports. Exporting is as simple as one line of code. This saves your plot as a high-quality .png file. You can also save it as a .pdf or .svg if needed. Use the DPI argument to control the resolution. A higher DPI means a sharper image. Got stuck? Don't worry, it happens to all of us. Let's troubleshoot a few common errors. Sometimes, errors pop up because the libraries are outdated. Fix this with pip install --update matplotlib. Getting an error about mismatched axis shape. This usually means your X, Y, and Z arrays don't align. Always ensure they are the same shape. Consistency is key when plotting. Alright, let's add some spice to our visualization with a bit of interactivity. Imagine having a slider that lets you control how you view a 3D plot. Sounds fun, right? Let's dive in. First things first, we need to summon our tools. Think of these imports as our toolkit for the project. Here's the rundown. Matplotlib.pyplot is our main artist for drawing plots. We call it PLT because, let's face it, we are all about saving time while coding. Then we bring in the Axis 3D to unlock the magical powers of 3D plotting. Of course, we need NumPy, our data scientist friend, for handling numbers, and finally, the star of the show, Interact from IPy widgets. This is what makes our plots come alive with interactivity. Next up, we need to create some data. Think of it as sketching the grid lines for our 3D surface. Let's do that. First, we use the mp.namespace to create 50 equally spaced values for both the x-axis and the y-axis. These values range from -5 to 5, covering a decent space to display our plots. Then with mp.meshGrid, we weave these x and y values into grid. This step is like drawing a checkerboard but in 2D space. Finally, we calculate the z-values. This is where the math comes in. The formula here gives us a smooth wave-like surface based on the distance of each point from the origin. Trust me, the results will look super cool. Now comes the fun part, creating a function to update our plots dynamically. This is where the magic happens. Here, our function update_plot takes one argument, angle. This controls how high or low we are viewing the plot, like adjusting your camera's angle. Inside the function, we'll create a new figure and add a 3D subplot using projection equals 3D. The real eye candy happens with ax.plot_surface. This generates the 3D surface, and we're using the Variadis color map for that sleek gradient look. Finally, we'll call the view_init, which sets viewing angles. The elevation changes dynamically with angle, while the azimuth stays fixed at 120 degrees for this demonstration. And with the pyplot.show, our update plot is displayed. Alright, our plot is ready, but it's still static. Let's breathe life into it with interactivity. This one line connects everything. The interact function takes our update_plot function and pairs it with a slider from the angle parameter. The slider ranges from 0 to 90, giving you full control over the elevation of the plot. Try it out and see how smoothly the view changes. It's so satisfying. Colors are more than just aesthetics. They help your audience interpret the data. Let's pick the right color map for the job. Different color maps work for different data types. For example, use Variadis for scientific plots, cool warm for temperature data, or plasma for a vibrant look. Always remember to pick the one that enhances your story. Now let's take this to the next level with an animation. Imagine the plot spinning smoothly on its own, like a mesmerizing centerpiece at a party. Here we'll call in the function animation from Matplotlib. This is our animation expert. It handles the repetitive task of updating the plot frame by frame. To make the plot spin, we need to define how each frame looks. Here is the update function. The frame parameter represents the current frame of the animation. We keep the elevation fixed at 10 degrees, while the azimuth changes with the frame. This makes the plot rotate smoothly around the z-axis. Think of it as setting a camera on a lazy Susan. Now we'll put everything together and let the animation roll. First, we create a figure and add a 3D subplot. Then we plot the surface using the same data as before. This time, we add edge color equals none to keep the surface smooth and clean. The restart here is fun animation. We pass the figure, our update function, the number of frames, which is 360 for a full rotation, and the interval between frames. And finally, with the pyplot.show, you can enjoy the spinning 3D plot in all its glory. We've covered a lot today: scatter plots, surface plots, terrain visualization, customization, saving plots, debugging, interactivity, challenges, and even animations. These techniques elevate your visualization and make your data shine. For our next tutorial, we'll dive into creating interactive 3D visualization with Plotly, where your plot comes alive with zoom, pan, and hover features. Subscribe, like, and stay tuned. Until next time, happy coding.